This lecture is about for comprehension and maps. This is the example from the Scala video lectures. We are implementing mini database of books using list. Books are implemented as a case class, which has two fields, title and authors. And authors is another list of strings. This is an example of the query. First, we converted the mini database books to a set. So we have this book set. Inside this first for comprehension, we first extract book B1 from the book set, and we extract another element B2 from the book set. So in this way, we generate every possible combination of books from book set. Next, we compare the two books are identical and proceed if they are different. Now, we are going to analyze every possible combination of books, but we will never compare the same books. Next, we extract author A1 from the set of authors of book B1 and extract author A2 from the set of authors of book B2. Finally, we compare the two authors and proceed only if the two authors are identical. And if so, we include A1 in the result of the for comprehension. If we think about the meaning of this query, it means that we are trying to find the set of authors who authored more than one book. And the point of this slide is, in the first line of this for comprehension, we analyze a collection of a type set. So this book set has a type set. And as a result, the entire for comprehension is going to have the same type set. So in other words, the first collection that we analyze inside the for comprehension is going to decide the type of the entire for comprehension. Even if we analyze collections of different types, for example, list, in the middle. So there's a good reason that we convert the books to a set here and analyze the book set instead of books. If we analyze the books here instead of book set, books has a type list. So the entire for comprehension would have the same type, list. As a result, the same author may appear multiple times in the final result of a for comprehension. So there's a good reason that we convert books to a set before we execute this for comprehension. Now let's find out why the first collection that we analyze inside the for comprehension decides the type of the entire for comprehension. Recall that whenever you have map, flat map, and with a filter, you can use a for comprehension. For example, you can use a for comprehension even on option type. Option type is basically a special type of a list where you can have at most one element. So just like you can use a for comprehension for list, you can use for comprehension for option type as well. And we can mix different collection types inside the same for comprehension, as we have seen in the previous example. Now, let's analyze list A with their method shown over here. So the flat map, which will be used in translating for comprehension, takes another argument of type then traversable ones B and returns list of B. We don't have to worry about the precise definition of then traversable ones, but we can think of it as the type of a collection. So the rest of the for comprehension is going to generate then traversable ones of type B. So the final element is going to have type B. Still, the flat map returns list of B. not gen traversable once B, because we start with this list of A. So the type of the first collection inside the for comprehension, if it is a list, then the final result of for comprehension will be list as well. As a side note, this with filter is a non-strict, and non-strict is basically another name for lazy. Here we have two semantically equivalent programs using flat map and using for comprehension. In general, using for comprehension produces a program easier to read than using flat map directly. But it depends on the level of expertise of the programmer as well as the particular problem at hand. For example, in the first case, it's immediately clear that the entire expression is going to generate a list because we have this toList method applied at the end. However, in the case of for comprehension, we have to analyze the type of the first collection inside the for comprehension in order to find out the type of the entire for comprehension. In this particular example, it's pretty easy to see the type of the first collection because we have an explicit application of a toList method. But that may not be the case in general. And also, we have to know that the type of the first collection inside the for comprehension decides the type of the entire for comprehension. So it's up to you which style is better for you. As a minor note, whenever you apply map followed by flatten, you can always use a flat map. These are examples of creating maps and accessing maps. In the type of map, we have two type parameters, the first for domain type and the second for the range type. In this example, we are creating a map Roman numerals where we have three mappings. This arrow has a special interpretation in Scala. It's just another way of creating pairs. For example, in this case, we actually create pair of string v and integer 5. So this arrow is just a syntactic sugar, which is translated to pairs. And here we create another map, capital of a country. And this is the first way of accessing map, which is translated to capital of a country, apply with argument US. So in this case, the key US must be defined in the map capital of country. Otherwise, it is going to raise an exception. So you have to know if the key is already defined in the map. If you're not sure about whether the key is defined in the map, you could use this get method, which returns a sum if the key is defined and returns none if the key is not defined. In this way, you can create maps and access maps. A common way to create a map is by converting list of pairs by applying this toMap method. In this case, you have to make sure that all the keys are distinct in the list. Otherwise, some mappings will be lost, and you cannot tell in advance which mappings will be lost and which mappings will survive. In the first example here, we have a list of pairs of integer and string, and all the keys are distinct. So when we convert this list X to map, all the mappings survive. In the second example, we have 4 mappings from integers to strings, but we use the key 1 twice. So when we convert Y to map using this toMap method, one of them is dropped. And in this particular example, this one method to hi survives and one method to hello is dropped. But and in general, you cannot tell which one will be dropped and which one will be included in the resultant map. So you have to check yourself manually that all the keys are distinct. Here we revisit the option type. The best way to interpret the option type is to think of it as a special case of a list with the constraint that it can have at most one element. So just like list is covariant in its argument type, option is also covariant in its argument type. So if A is a subtype of B, then option A is automatically a subtype of option B. And option type is two constructors, some and none. And none extends option nothing. And nothing is a subtype of every type. So therefore, you can reuse this none for every option type. Just like nil can be used for every list type.